All right, today we're going to talk about the basic overview of the 6 special quadrilaterals that we're going to study in this unit. So quadrilaterals are 4-sided shapes, but some shapes have certain properties and they have special things, and that gives them specific names. So for example, if we have a quadrilateral that has opposite sides are parallel, so both sides are opposite and they're parallel, and usually that's indicated by arrows. That's going to be called a parallelogram. All right, so opposite sides are parallel, and usually there's a marking that says so. If we have a parallelogram now, so we already know that opposite sides are parallel, but it also has 4 congruent sides, that's going to be called a rhombus. Now we go back to the parallelogram and we have 4 right angles now. So we have opposite sides are parallel and the 4 right angles are going to make that a rectangle. A parallelogram with 4 congruent sides and 4 right angles is going to be a square. So right now you see that we start off with a 4-sided shape, and then we add parallel sides, and then we add congruent sides and right angles. And we have a list now of special quadrilaterals. All right, if we have a quadrilateral that has 2 pairs of adjacent sides, so in this case, these 2 sides are going to be adjacent, these 2 sides are going to be adjacent, and they're congruent, this is going to be called a kite. All right, down here we have a quadrilateral with exactly 1 pair of parallel sides, and this is going to be a trapezoid. We have a special trapezoid in which the sides are congruent, and that's going to be an isosceles trapezoid. All right, so here's some examples based on appearance. So here we see 4 congruent sides, and we have 2 shapes that have that, a square and a rhombus. So right now, we are going to give, this is the rhombus because there are no right angles on this. Okay? All right, the next one here, this looks like these 2 are parallel, and this is going to make that a trapezoid. Okay? Also, if we want to classify this in as many ways as possible, right? Not only is this a rhombus, it would also become a parallelogram. It'll also be a quadrilateral. If this is a trapezoid, it's also going to be a quadrilateral. All right, over here, this definitely does not look like the sides are the same, but it looks like the angles are 90 degrees, and this is going to be a quadrilateral, a parallelogram, and a rectangle. All right, so here's a diagram that kind of overviews what we just did. So we have quadrilaterals, and then depending on the number of parallel sides, we can break up those shapes into different groupings. And then from there, those properties are passed down. And what you end up having a lot of times with a chart like this are true and false questions. So for example, are all rectangles squares? So are all of these squares? And we're going in a down direction. And we're going to find out that that's actually false. Over here, all squares are rectangles. All of these are rectangles, and we're going in the up direction, and that's going to be true. So anytime the first thing the first shape is given, and you're going up, that's going to make the statement true. Anytime the first shape is given and we're going down from there, that's going to make it false. All right, here's some examples where we're going to plot coordinates and then figure out what we need to do. So in this case, we have slopes, and the slopes are going to determine parallel lines. So if slopes are the same, they're parallel. If slopes are opposite reciprocals, they're 90 degrees, they're perpendicular. So in this case, the slope of AB is going to be 1 and then 5 over. The slope of CD, which would be its opposite side, is also the same. So because they're the same, we know they're parallel. All right, BC is going to be negative 5 over 1, and AD is going to be negative 5 over 1. So these are also the same, so these are parallel. We also notice that these 2 slopes are going to be opposite reciprocals. So that means that AB and BC are going to form a 90-degree angle, and that is going to be true for all of these. So right now, we have opposite sides are parallel. That makes it a parallelogram. We have 90-degree angles. That's going to make it a rectangle. So the last thing to do is prove what the lengths are. And if the lengths are the same, which they are, using the distance formula, then we now have a square. All right, here's an example that's not graphed. And in this case, they tell us it's a rhombus. So knowing the properties of rhombus, opposite sides are parallel and congruent, we can solve this. So the first one here would be 5a plus 4 is equal to 3a plus 8. We have the answer for the variable is 2, and then we plug it back in. So 5 times 2 is 10 plus 4 is 14. So the length would be 14. Over here, this would be congruent to this. Now, because it's a rhombus, we know all sides are the same, so technically we don't need to use this to find the length of the side, just the value of the variable. And we end up getting b is equal to 4, and if we plug it in again, 4 times 4 minus 2 would give us a side length of 14.